అందరికీ నమస్కారం అండి. Today is another good day and on Vedic mathematics. In fact, today is the last day of 5-day session on Vedic mathematics. After 1 month of instructions on various topics on Sanatana Dharma, we have started with Vedic mathematics in the second month. The next topic will be Panchangam by Dr. Sundareji. It will be tomorrow, day after, morning, same timings. She is not available on working day, so we have scheduled on weekend. All of you are required to block your calendar and come. And also tomorrow evening there will be a webinar. Saturday evening there will be a webinar by Dr. Shastri Garu. Now let us start the session with Vande Mataram by Challa Chittibabu Garu and Chant Prarthana by Dr. Sharda. So I request all of you to stand up and recite Vande Mataram along with Challa Chittibabu Garu.
Vande Mataram, Vande Mataram, Sujalam Sufalam, Malaya Jasitalam, Sasya Syamalam Mataram, Vande Mataram. Suprajyotsna pulakitayaminim pullakusumita drumadala shobhinim suhasinim sumadhura bhashinim sukhadam varadam mataram Vande Mataram Vande Mataram.
Vande Mataram. ధన్యవాదములండి చిట్టిబాబు గారు. Now let us request Dr. Sharda ji to chant Prarthana, please.
Sarvebhyo Namo Namaha. Let us do meditation for 1 minute. Let us be at peace without any thought process, followed by Omkara. Om Gananantva Ganapatigum Havamahe Kavim Kavinamupamashravastamam Jyeshtarajam Brahmanam Brahmanaspata Anashrunvannutibhisi dasadanam. Om Shri Mahaganadhipataye Namaha. Om Prano Devi Saraswati Vajebhirvajinivati Dhinama Vitriyavatu. Om Shri Mahasaraswatyai Namaha. Gurureva Gati गुरुमेव भजे गुरुणैव सहास्मि नमो गुरवे न गुरोः परमं शिशुरस्मि गुरोः मतिरस्ति गुरौ मम पाहि गुरो ज्ञानानन्दमयं देवं निर्मलस्फटिकाकृतिम् आधारं सर्वविद्यानां हयग्रीवमुपास्महे श्रुतिस्मृतिपुराणानाम् आलयं करुणालयं नमामि भगवत्पाद शङ्करं लोकशङ्करं शङ्करं शङ्कराचार्यं केशवं बादरायणं सूत्रभाष्यकृतौ वन्दे भगवन्तौ पुनः पुनः ईश्वरो गुरुरात्मेति मूर्तिभेदविभागिने व्योमवद्व्याप्तदेहाय दक्षिणामूर्तये नमः असतो मा सद्गमय तमसो मा ज्योतिर्गमय मृत्योर्मा अमृतंगमय ओम शांति शांति शांतिः मातृदेवो भव पितृदेवो भव आचार्य देवो भव अतिथि देवो भव ओम सहना भवतु सहनौ भुनक्तु सह वीर्यं करवावहै तेजस्विनावधीतमस्तु मा विद्विषावहै ओम शांति शांति शांतिः धन्यवादः स्वस्ति
ధన్యవాదములండి శారద గారు.
धन्यवादः
Yeah, now let us request Goutham ji to continue his webinars.
नमस्कार सभी को नमस्कार. I'll start the presentation. How many of you tried these different by Vedic online method? At least 10 places of these, 10 places of these. How many people tried this? How many of you tried? So is there any doubt? I will discuss in the beginning. If anybody has any doubt, I can discuss this 13 by 19, 19 by 29 and such some situations. Should we?
People should interact, talk. Somebody has a doubt, Shastra Garu, now you can raise the doubt.
Sir, I could not understand 1 by 19, the basic method.
Acha. Okay.
So I could not practice it.
Oh. So there should not be any gap in understanding. So I'll come to white screen. So should I start with something by 19 or something by 29? Or to start with by 19. Let us see. 19 is the easiest one. So say I do not do always 1 by something. I say, let us say I do by 11 by 19.
Okay.
What I will do, I will not divide 11 by 19. From the expression, I will do actually 11 by divided by 20. But that too, not exactly 20. sorry. Instead of 20, I will divide by 2. 19 plus 1 by 10, because actually I will be dividing, I wanted to divide by 20 according to the series, but automatically it will be taken care of when I go to the next decimal place, when I throw that result in the next decimal place. So 11 by 20, 11 by 2, what I do? I do not say that this 11 by 2 is say 5.5. No, not that. It's not 5.5. And 11 by 20, rather 11 by 20 is 0.55. That is the most important. 11 by 20. 11 by 20 is 11 by 20. So it will be, you want to know that is near about something. So that is just to check with our conventional mathematics with this. But how will do the 11 by 2? I will start with 11 by 2. This is not this. So 0. When I divide 11 by 2, what is my quotient and remainder? I will be always doing quotient and remainder. Quotient I write in the big format and remainder I write in small format. So what is the quotient? When I divide 11 by 2, what is the quotient?
5.
5. 5 is the quotient. And what is the remainder it leaves?
6.
No. 2 5s are 10, remainder is 1.
This is remainder, not the remaining ones.
Remaining is 1.
Remainder. Now it makes it 15.
Oh,
This-
15.
This remainder is taken as a tens digit. Tens digit. Two digit number, remainder becomes my tens digit. Ekak dasak, it becomes the dasak. What do you call in Telugu? I don't know. What do you call in unit dasak, ekak dasak satak? Unit 10, 100. What do you call in Telugu?
It is Padosa.
So
Padi.
so it becomes 15. So when I divide 15 by 2, what happens? What is my
7.
quotient? Remainder?
7 and 1.
7 and 1.
1.
7 and 1.
It is 17 now.
Yes.
8. 1.
8, 1. Yes.
18, 9, 0.
9 and 0. 0 always we write sometimes or not write, doesn't matter. But to complete it, we should write also when we write.
Then 4 and 1.
4 and 1.
Then 7, 0.
7, 0.
3, 1.
3 and 1.
6, 1.
6, 1.
1, 2, 3, 4, 5, 6, 7, 8. And one more. 3, 8, 0.
8, 0.
Now these things, 9 complement can be taken.
Exactly. But very good, very good. I understood. So if I do also same thing, 4, half of that, the 8, half of 8 is 4, half of 4 is 2, and half of 2 is 1, and then 1 even divided it becomes 0. But you can do also by 9 complement. You keep on doing others by 9 complement. Okay. This is 2, this is 6, this is 3, and this is 1. It started with, that means it will be had I completed like this all remainder, it would have been left a remainder 1. This is 3. So it is really 3 actually, not 13. So 11, 1 and 1, so that comes back to the 11. And that means my cycle is complete. I put a dot here, put a dot in the top, my cycle is complete. You got it, everyone got it?
Up to this one, I got it. But what is the next step?
Next, no next step. This is 11 by 19 is complete with 18 digits.
No, but very here, the repetition of the figures. Here there is no repetition, right?
No. You continue. This 11.
Oh, from this one it continues. Okay. Okay.
Again, it comes back to 5, 7, 8, 9. But therefore, you put a dot here, no? This is
Okay, sir.
recurrent
Understood.
decimal. It will never
Understood.
end. It will never end. It will never end. And therefore, had it been ending here, the whole thing, 18-digit number, should have been divided by 1 followed by 18 zeros. That is the end of it. But here it will be 18 numbers of, we have to divide it by 18 numbers of nines, and which actual factor has a 19, and the result will be 11 by 19. Okay.
Sir,
So
1
what
by
is-
19 in this method we do.
1 by 19
We
Would
do
have
in this
started-
method.
would have start from here. Point
Ah,
0.0526.
then from that 11 by 19, how to get?
11 by 19. That's what I did just now. Na? 11 by 19 start with. Start 11, divide 11 by 2. 11 by 2, not 1 by 2. 11 by 2. So earlier it was point. My quotient was 0 and remainder 1. Now quotient is 5 and remainder 1. There's the difference. Okay. Whatever you are.
I think the doubt of Shastri Garu is that 11 by 19 you have done. From here, how do we get 1 by 19?
1 by 19. Oh, I see.
Yeah, 1 by 19 we get
Then I have
from
to, I have to
4
complete
to,
this.
no.
This.
Yeah, 4 to 1, the bottom line is 1 is 0.
Ah.
So the next series 0, 5, 2, 6, 3, 1 and so on so forth is 1 by 19.
This is 1. This is C. This is the 1. 0, 1. 0, 1 is 1. And 1, 1. This 1, 1 is 11. Okay.
So 11 is, it is coming at the end after the second line 6, 3, 1.
The starting
1,
with
1 is there. After that, whatever comes is 11 by 19. Shastri Garu, you got it?
Little bit confused.
Yeah.
what is
There are 2 ones here.
Right.
2 ones here, but
Which-
one.
Which
yes,
one is to be?
one of the ones is with remainder 0, and that is 1. And other one is with remainder 1, and that is 11.
Oh, this is 11. This one is the starting point.
This is the starting
Right.
point. This becomes my ending point.
Oh, acha.
The starting will be always ending.
In fact, this series of 5, 7, 8, 9, 4, 7, 3, 6, 8, etc. If you go and if you, for example, want 18 by 11, then you see in the top line 5,
18
7,
by 19.
8, 1, 8 is there. So from there onwards, 0.947368432 it will be the series.
18 by 19.
Oh,
Whereas 8 by
Oh.
19, please, Shastri Garu, you told what will be the 8 by 19?
Yeah.
8 by 19, 8 by 2.4.
No, but no. Here in this.
See, 0.4. This point.
Point not 0.4, 0.4.
0.4421052631578.
Right.
Yes.
You got it now.
So whatever I want, I have to start from next to that.
So we need not to do the actual division to find out.
Right.
Exactly.
Okay.
So every time, suppose you are some child is asked to do, say, tomorrow's task is, you do 1 by 19, 2 by 19, all these things up to 18 by 19. So what we will do by conventional method, he will be, full exercise book will go. And here, you just evaluate once for all for any of the fractions of your choice, say 11 by 19 or 9 by 19, whatever it is. Now, once it is could do, it is done once for all the fractions, all the 18 fractions.
Sir, one more doubt. More doubt.
Yes.
This is a 1 by 19 or 11 by 19, whatever it is. What is the difference between 1 by 19 and 1 by 29?
1 by 29, we keep dividing by 3 instead of 1.
No. Suppose I was given a series 0.5789473682442105263. If I am asked what is the fraction for this one, how I will find out?
No, you have to do it again for 1 by 29. There is a
No,
double
separate.
series.
Suppose you are given like this, and see, this is the repetition of this thing. This is the cyclic. So if you have a very already 18-digit number, you have to divide it by 18 numbers of 9. Then the calculation has to be done, division you do, and then find that it is ultimately 11 by 19.
His
If you have
question
a
is
very strong
for
calculator,
29.
you can do it. Result will come as 11 by 19.
No, Gautamji, his question is 11 by 9 by 19 is over. If it is by 29, what to do? So you has to
same thing,
do a
by
series. You has to do the series again for 29.
Yeah. For 29, yes.
No, is there any correlation between 1 by 19 and 1 by 29, 1 by 39?
No.
Oh, acha, acha. Okay, sir. Understood.
Okay, sure. So I think some doubts have been cleared. With practice, lot of doubt will be cleared. Periodicity I covered yesterday. Now today, let us go to divisibility rules. Since our childhood, we are asked this question that without actual division, can you tell me that something is divisible by another thing? Some dividend is divisible by a divisor. Whether some number is divisible by 2, 3, 4, 5, say 6, or even 9, 11, and so on. But very carefully, normally this which is never asked if it is the divisible root of 7, 13. Nobody asked, at least since our childhood. Somehow, some people of their interest, they started learning this thing later. But I found, in terms of Vedic mathematics, in the method called oscillator, there is no difference between finding about 3, 9, 11 on the one hand, and 7, 13. Only oscillators are different. And to have set the background, I start with divisibility with 2 and 5. Since 2 and 5 are factors of 10, which is the base of our decimal system, the rules of divisibility by 2 are factors of 2, and 5 or 2 are powers of 2, and 5 or powers of 5 are similar, and they're quite easy. Divisibility by 2 to the power n requires that last n digits to be divisible by 2 to the power n. So 5, 7, 3, 5, 6 is divisible by 4 because we don't have to look about what is before that. Last 2 digits. 56 is divisible by 4, so the whole thing is divisible by 4. Divisibility by 5 to the power n requires last n digits to be divisible by 5 to the power n. That means this number is 543275 is divisible by 25 because 75 is divisible by 25. So for divisibility by 2 only, I see only the last digit. So 13579 are not divisible by 2, and 2468 and ending with 0 are divisible by 2. I know it. And for 5, all the any digit ending in 5 and 0, 5 and 0, these are all divisible by 5. But in case of 25, I see always 2 at a time, 25, 50, ending in 75 and 0, 0. And something like, always like this. For 125, I should see last 3 digits. So that way, it's about 2 also. If we want to divide by 8, it will be last 3 digits you have to test. So that is about 2 and 5. Now, divisibility by a composite number. Composite number, in general, it is called, say, suppose you know by 3, know by 2, then something divisible by 6. How to determine it is divisible by 6? Because it is divisible by 2 as well as divisible by 3. So, for example, here, in this page I did do it, but what is the divisibility by 3 we do? That sum total is divisible by 3. So 42, 4 plus 2 is 6. So 6 is divisible by 3. In addition to that, 42, since ending in 2 is divisible by 3. So therefore, it is divisible by 6. Some echo is coming?
No, it's okay.
Okay. Similarly, 135, 5 plus 3 plus 1 is 9. It is divisible by 3. But it is ending in 5, so divisible by 5 as well. So it is divisible by 15. So that was composite number, we do like that. Components, small components. But divisibility of number ending in 1379 has general method of called osculation. And which gets trivial form in case of 3, 9, and 11. So therefore, we learned it separately. We learn it, but others we skip. That's what I told in the beginning. Divisible by 3. A number is divisible by 3 if sum of all its digits is divisible by 3. For example, the number 5, 4, 2, 2, 3, whatever big numbers, 2, 3, 4, 5, 1. You add up all them. You do a repeated add. Once it is, after adding also it becomes large. You cannot determine. You again add. Is divisible by 3 because sum of all digits, which is 24, is divisible by 3. Divisibility 9. A number is divisible by 9 if sum of all its digits is divisible by 9. For example, the number, this is 8, 4, and so on, is divisible by 9 because sum of all its digits is 27, is divisible by 9. It is divisible by 9 as well as divisible by obviously 3 because 3 is a factor of 9. Whereas 24, that is divisible by 3, but not by 9. It can happen. Divisibility by 11. A number is divisible by 11 if the difference of sum of alternate digits, say even and odd position digits, is 0. Or is divisible by 11. For example, the number 934571 is divisible by 11 because on one side we add up all the 1, 2, 3, 4, 5, all the even positions digits or all the odd position digits. So 9 plus 4 plus 7 alternately, 3 plus 5 plus 1. So add up them and subtract. So it is 11, or it could have been 0. In case it is 0, or 11 by or 22 and so on, it will be divisible by 11 because that difference of alternate sums divisible by 11. Find whether the number exercise you can take. You can note down exercise. This is divisible by 3, 9, or 11. Okay. So far in our childhood, we learned this much about our division. Now, what is the osculation method? This is the basic method of osculation or to determine divisibility without actual division. A 2 or more digit integer n can be expressed in the form n is equal to 10r plus u, where u is the unit digits and r is the rest comprising of 10 digits and beyond, larger digits, excepting u. So you can always write like that. Osculation is a basic method to create a smaller number to t, test number, you can say, test number, smaller number, test number. It is actually, what is that? T is equal to mu. 10 is equal to m times u, where the multiplier m is called the osculator. It is being said that the integer n is being osculated by this small m multiplier, this multiplier of the osculator. To get why I'm using the symbol m, because O always, if I use O for osculator, it will be confused with 0. So oscillator, I'm using m, which is a multiplier or the oscillator. Oscillated by m to get capital T. The process can be recursive by same oscillator m. So you understood now how it is done? Instead of 10r plus u, I do r plus mu. So automatically it gets reduced. Process can be recursive. The unit digits t can be multiplied. Unit digits of t, another new t, can be multiplied by a same oscillator and added to rest of digits of t. Osculation is an efficient method for testing divisibility. It is a method to determine the required m given a number capital N and a divisor d. In fact, for a divisor d, it is a oscillator. I mean, it doesn't depend upon the number n, but For the divisor, there is a particular D. Maybe I could write this earlier. Ending in 13709. D must be ending in 13799. I cannot do the oscillation method for something ending in even number or ending in 5 or 0. The oscillator M can be found with the following consideration. The persons who are slightly algebra. Consider Mn minus T. Mn minus T, I write the actual number I wanted to test. This is the n, this particular number on which I want to do divisibility test. So Mn minus T is equal to M into, I told that the n is equal can be expressed as 10R plus U, and T was my R plus Mu. That was my, that very formula about NR minus NR plus U and R plus Mu I discussed. So this is this will be the calculation, and then from this little calculation it will be as a homework you can see. Let us now consider divisibility by a number, say D, divisor D. If we can find that oscillator M such that 10 minus M, 10M minus 1 mod D is equal to 0, that will mean that Mn minus T is equal to 0 from this algebraic point. Thus, once the proper oscillator M is found, our job will be to test T for divisibility by D. If once the T is divisible by D, automatically the this part also will be divisible by. Once this is divisible by T, D, this divisor, this Mn also will be divisible by D. From the and it will lead to M mod N is equal to 0 because M mod N is equal to 0. Now this is the thing how T is equal to this. Once you have to find how to find it out. We found M so that 10M minus 1 mod D is divisible by D. This is the formula to find the oscillator of a particular D. That 10 times any number, 10 times a number, okay, minus 1. That means near about that. Suppose 40 it is 39. For 20 it is 19. So one less than a 10 digit number. What is that number that is D divides that? That will be my oscillator. I will come to that. Example, let us test whether 343 is divisible by 7. First we find oscillator for 7. What is the procedure to find the oscillator of 7? We find that 10 into 5 minus 1, that is 49 is divisible by 7. Thus, oscillator M is 5. So, okay, that is the idea. Any confusion in that? Something I want to find that whether I multiply 10 with, keep on multiplying 10 with numbers and minus 1 of that. So, first we do 10. So, 10 minus 1 is 9. 9 is not divisible by 7. So I reject that. So 1 is not my oscillator. 10 into 2 minus 1. 19. 19 is not divisible by 7. So it is 19. So 2 cannot be my oscillator. 30 minus 1, 29. No. 40 minus 1, 20, 39 not divisible. But 10 into 5. 50 minus 1, 49. Divisible by 7. So 5 is my oscillator for 7. Thus, oscillator for 7 is 5. Once we found M, we execute the following process. 343 is you are doing T is equal instead of N, we are doing T. T is equal to here. This 34 part, the rest part from this leaving the unit, the rest part, and plus 3 into 5 is 49, which is divisible by 7. So 345 is also divisible by 7. A large number, let us take a large number. 64724. It becomes 64724. 6472 plus this 4 into 5. So 647, it becomes 6492. We again do like this oscillation. This arrow means I'm doing oscillation. 649 plus 2 into 5, which is 659. It got reduced to again 65 plus 9 into 5. This 9 into 5. 111, 11 into this thing, 11, not divisible by 7. So by backtracking, this 11, 100, 10, 659, these none are divisible by 7. None will be divisible by 7. Another example, case divisibility of this by 13. Let us first find the oscillator of M, oscillator M for 13. We find 10 into 4 minus 1, 39 is divisible by 13, so M is equal to 4. Oscillator is 4 for 13. We do 1100, 635 is oscillation 1160 plus 5 into 4, 118. So 118 plus 3 into 4 again, so 130. And again it becomes 13 plus 0 into 4, so it becomes 13, so this is divisible by 13. You understood? Any question? First, there are two parts. First, you have to find out the oscillator, and next one you have to find the process. Now, where is any confusion? Is there any confusion in finding out the oscillator? Is there any confusion in the process of the oscillation? Tell me, please.
Excuse me. I could not understand. First of all, M. First of all, we have to find out M or D. How it comes from this example?
No,
this 5.
D is given to you. Somebody tells D is given to you. Somebody tells that tell me whether this number. Suppose give a number. Suppose this number is divisible by 7. Okay, this here I didn't do 7. Let me do it 7.
The previous one. This is right, sir.
Huh? Previous one.
Which example you are referring?
Okay, let us.
Okay, 343 is divisible by 5. Here, how we get 5?
No.
My question is, how we are getting that 5?
5. So, we keep on trying that something.
Trial and error method.
10 into something minus 1 is divisible by 7. So, we find that 10 into 5 minus 1 is divisible by 7. So, that's what I got 5.
Oh, that means by trial and error, we have to find out this 5 number, right?
For 7, it is 5. How it is coming? So,
then M is 5. Oh.
M is 5. So, you are giving a number 23.
Then what is D actually?
D is this one. You are asked to
Divisibility. Divisibility.
Divisor. D is divisor.
Divisor.
You are asked
divisor.
You are asked to test the divisibility with 23. That means D is 23.
Then what is mod D?
Something mod D means that is divisible by 23. Mod, if something mod,
Mod is modulus, no?
Modulus. Oh yes, sorry. Mod is modulus.
Then what is modulus?
In mod D is equal to say something X. So X means that when N is divisible by D, it leaves the remainder X. So 0 means it is divisible, and non-zero means it is some remainder is there. No, you always need remainder. So 4 mod 3 equal to 1. All right, earlier I did.
4 mod 3 means 4 by 3.
Suppose I do say, I remember I do always 11 mod 2. 11 mod 2 and 11 mod. If you tell me what are these?
Sir, what is a mod stands for, sir? MOD is the short form of which word, sir?
It is when 11 gets divided by 2, what is the remainder? That is called mod.
Mod is remainder.
Mod is remainder. And in Excel, MS Excel, it is said mod. We do it like that. Mod in mod d. In the expression we write, but in the Excel is equal, it's called A is equal to mod. The mod function is that n comma d. N comma d. This way we write. So please tell me 11 mod d2 is what?
11 mod 2 is 1.
1. And 11 mod 3?
2.
2, yes. So that way.
Am I correct, sir?
Yeah, yes, very correct.
Okay.
So remainder when n is divided by d, what is the remainder? It's called mod. Okay.
Okay.
Now, what I was telling, again I'll clear this and again. So suppose you are given want to test divisibility by 23. What is the mod you find? What is the aim? Sorry, mod, oscillator, aim.
Sir, 7 can be the oscillator. 10 into 7 minus 1.
So we know that 26 is divisible by this 29 is a factor, not sorry. Here you have to write factor. 23 is a factor of 69. 23 is a factor of 69. Repeat. 23 is a factor of 69. So therefore, 7 is my oscillator. M is equal to 7 in case of 23. D is equal to 13.
Party minus 1.
40 minus 1. So my oscillator is M is equal to, this is 39 is divisible by 13. So my oscillator is this one, 3. 10M, when 10M minus 1 is divisible by D, mod of this thing is divisible by D, okay, divisible by D. 10M minus 1 is divisible by D, that means M is the oscillator. So 40 minus 1 is 10 into 3. 10 into 3 minus 1 is divisible by 13. So
It is 4, no, sir?
No,
4.
4. Oscillator is 4.
4. 10 into 4 is 40.
Sorry. Oh, I'm so sorry. I'm out of mind probably. It is 4. Yeah. 10 into 4 minus 1. So yes. So you corrected me very good. I make also mistake some in flow of my this thing. I make a mistake. 10 into 4 minus 1 is 39. So 4 is my oscillator. Okay. Understood? 10M minus 1 is divided by D means M will be my oscillator. Any other example you want? For 7, how do you find it? For 17, let us see, D is equal to 17. What will be my oscillator?
It will be 7. No, not 7. 150 you can take, sir. 120, sir.
12. 12 will be the oscillator, sir.
Exactly.
Yeah, it will be 12.
So this 12, when 10 into 12, minus 1, which is 111, 119. Okay. 119. So, so what should be that oscillator? 12. 10m minus 1 is divided by d, so it is 12. So for this thing, I have to do by 12. But there is also another catch. This I would have covered slightly later. In case of 17, in case of 7, say, 7 oscillator was what? I got
5.
5, because my 49 or 50 minus 1. I didn't want to confuse you right now, so it's divided by 1. So 50 minus 1, so 5 is my oscillator. But on the other hand, 7 is also a factor of 21, which actually is 2 into 10 plus 1. I didn't discuss this thing so far. Only see that oscillator M can be used as M is equal to 5 here in case of 7. M could have been also minus 2. I'll come to that. It will complicate you right now. Just to first, let us do only for positive. Then I'll tell you. This oscillation part is okay?
Yeah.
The procedure is okay. Test divisibility of this thing by 23. We
It's
find.
okay, sir.
Huh?
Okay, sir.
This is okay also. This is by 23. To find, we have seen that divisibility by 23. Therefore, oscillator aim is 7 in case of 23, and you do 41285. It goes to 4128 plus 5 into 7. Goes like this: 4163. Then 416 plus 3 into 7, 437. Then 43 plus 7 into 7. This 7 into 7 is 92, and 92 is plus 27, 23, and goes. And then backtracking, all these things are wherever you, because it is found, and all these things are also divisible. Positive, negative, and minimum oscillator. This I just wanted. Just. Earlier we did about 10m minus 1 divided by d. Now we see if 10m plus 1 is divided by d. All the algebraic consideration holds good with oscillator minus m. That is, t should be calculated as r minus mu. Earlier we are doing r plus mu. Now we have to do r minus mu. In this case, minus m can be called the negative oscillator. M oscillator, and it's negative, so I'm calling it negative. Moreover, if m is an oscillator, to test divisibility by d, m plus minus any factor into d will also be an oscillator. So 5 is there. So 5 minus 7 is minus 5. Minus 5 also will be oscillator. 5 plus 7, 12 also will be the oscillator for 7. 19 also 12 plus 19 also will be oscillator 19. But when my work will be over by using oscillator 5, why should I multiply something by 19 or 26 or so on? Who will do that? So, but what do my purpose of that, to make it minimum, I do sometimes subtract, like 5 minus 7 is minus 2. So minus 2 can be my oscillator. In case of 17, what can be my oscillator? Suppose I find that 12 is large. So what can be the minimum oscillator of my 17?
5.
Minus 5.
Minus 5. There are two ways. Either I do 12 minus. See, I found that 12 is a half of more than half of 17. So it cannot be the minimum. So 12 minus 17 I do, it becomes minus 5. Minus 5 is my oscillator for 17. Another is there that earlier 10 into 5 minus 1 was divisible by 7, but 10 into 5 plus 1 is divisible by 17. 51 is divisible by 17. So that I don't have to go up to 111, but I find that 10 into 5 plus 1, which is 51, is divided by 17. So 5 becomes minus 5 becomes my oscillator for another oscillator for 17. And it is negative, we can call it negative oscillator for 5, 12, 90. And the negative side minus 2, minus 9, minus 6, all can be used for testing. In case of 7. Table of the next page can be given a list of oscillator. Oscillator for 3 and 9 is plus 1, and oscillator for 11 is minus 1. And so therefore it becomes so obvious and that procedure looks one. Actually, if you keep on, in case of 9 and 3, we added up all this. We added up, no? And what happened? Some problem, my image got stuck or something like that?
Yeah, your image is stuck. Your voice is coming. Your voice is coming, but image is stuck. Now it's okay. It's coming. Yeah.
Oh, yeah. Something got. The response is slow actually. What I was telling? For 9 and 3, what to do? We kept on adding up all the numbers. How it is coming? Suppose I do T. So it is one time the unit. That means you add up with the rest. Again, one time this thing. If instead of 1 by 1 adding, we add together everything. In case of 11, it is minus 1. We always do minus 1 of the unit and subtract it from the rest. And again the new number you get, you always subtract. So instead of doing what you're doing, alternatively we are adding and finding the difference. So therefore this oscillator is there. Oscillation process is also there being applied in a different fashion. So we are not detecting that is an oscillation. For 3 and 9 it is plus 1 and for 11 it is minus 1. So the rules is simpler and obvious. Now here is the list of, you just study it. I'm clearing my throat. Okay. Kada. Any questions from here? Just have a look. Are they readable?
Yes, readable.
I could have written it aim also. Aim is my oscillator. So here is written N oscillator.
Sir, how to read this table?
Oh. You can take it, this oscillator I was using for aim, but it is written as N, okay? Now this is the 10 times N. Now I want to find out for how many numbers this oscillator are plus N and minus N. That means for which are the numbers for which oscillator is 1, 2, 3, 4, or minus 1, minus 2, minus 3, minus 4, and so on.
So for one oscillator value is 3, yeah?
What is that? What are you asking?
For n is equal to 1, oscillator is 3, yeah?
No, it's the other way around. Other way around.
For oscillator, for divisors 3 and 9, the oscillator is 1.
Acha. Okay.
For 19.
Divisors 3 and 9, oscillator is 1. And divisor 19, oscillator is 2. Okay. Okay, sir. And for negative value?
Huh?
Negative value?
Negative value, yes. For 7, the oscillator is -2. For 3 also it could have been -2, but why do you use when for 3 it is very simple with 1. What do you use -2? Not required. It just for
Then what are these numbers? 11, 21, 31? These are also divisible. Huh?
No. These for them also. For them also, this 10m plus 1, 10n plus 1. It is also there for them, the whole number also, it is oscillator is this thing. Therefore, I repeated this.
Okay, sir. Okay, sir.
And
Understood.
all the factors of that also will be the oscillator. Similarly, for 9, 19, 29, 39, 49, everything oscillator is these numbers. Okay.
Okay, sir.
But for 59, there is no factor, so I didn't write. But for 7, it is for 49, it is 7 is a factor. So 7 also, this oscillator is 5.
5. For 59, only 6.
For 19, we had the oscillator 2 is available for only 19. Can be used for only 19. But oscillator 4 plus 4 can be used for number 13 and 39 as well. For oscillator 10 can be used for 11, 33 and 99. But for 11, it is already a smaller number is there, which is called -1. Okay. 11 is in the top. No. So it is the divisibility. What did you do? 10n on the one side. I did 10n minus 1 and 10n
plus 1.
10n plus 1. Then I factorize all these things. I factorized. So therefore, these are my oscillator. Using negative method again. Please see. Testing divisibility of this thing by 7. We find that 10 into 2 plus 1, that is 21, is divisible by 7. So negative oscillator of 7 is -2. It will the following. Same way. You just look at that. It's the steps. You find out whether it is not done. Earlier we were multiplying by 5 and adding. Here it is. We are multiplying by 2 and subtracting even easier. It is converging even faster. Isn't it good? So note that for divisor ending in 1 or 7, it will be easier to use negative oscillator instead of positive oscillator. For example, in case of 21, it is 2 into 2 plus negative oscillator is -2, but its minimum positive oscillator is 19, because earlier we had some problem of 20 for 21, we are dividing by 19. So that same positive oscillator actually that one, a large one. So 10 into 19 minus 1, 189 is divisible by 21. So for 21, it will be horrible. Instead of that, for divisibility by 21 can be easily done by negative oscillator. Similarly, 10 into 5 plus 1 and 10 into 12 minus 1, both are divisible by 17. So that oscillators are -5 and 12. It is easier to use -5 instead of 12. Please practice some of them. In a white screen, let us practice. You tell me the number I want divisor. Somebody tells, please. Suppose I give a 6-digit number. Tell me one. Each of you tell one digit so that it is totally random. Want to test divisibility by which number?
13.
Huh?
13.
So far, 13. Okay, let us see. This is divisible by 13 or not. So what should be the procedure? What do you do next?
9 into
10 into 4 minus 1.
6, 4, 5. In fact, what do you do? 9 into 4. No. 9 into 4. 9 into 4. 36. So this is another procedure is there. This I cut. It is no more used. 9 into 4 is 36. 36 I do here. Write like this. Let's see what is the works or not. So it becomes 6, 4, 5. Double zero. Correct? Zeros I totally cut. This actually this shortcut has come. See? Nice. Also 5 I cut. 0 I cut. So now I am testing the divisibility 645 by 13. Now I cut also 5. So this becomes my 645. You don't have to take the permission of eliminating zeros. So I cut again.
Sir, we need to add that, no, sir, for that 36.
Oh, yeah. And again, I got a slightly absent-minded. Yes. Also. It may happen, actually. This may happen sometimes. So therefore, I got 36, and again, I got 36. I got very delighted. So let us do it. I said, let us do by, since I've already cut it, let us do by, not by 13, but I was doing by what actually? By doing this procedure, you please tell me now. So I committed a mistake. Now,
that was a negative oscillator.
Negative. What is that negative code oscillator? I'm testing divisibility for what now?
6, 7.
What is the number for which by negative oscillator is -4? There is one number only, because it is prime. Because it is prime.
41.
But the example I liked actually, because it got cancelled. So this is a case actually. Normally you do not get such cases always. So suppose I am doing by 41. It's not 13. 13 I'll do it again. I will repeat. So I'm just testing divisible by 41. So 9 into 4 is 36, and I subtract, it becomes 645. Again, 0 don't have to take permission or anybody to cut zeros, 64. Now this is, I do 5 into 4 is 20. 24. 24 is not divisible by 41. So therefore, 24 is not divisible by 41. So therefore, it is not 64 also. It is not 645 either. It is not 645 00 either. It is not 645 645 369. Okay. Now let us consider now. But here actually these are the classic example where some short can be there. Let us do now 13. 645 369. It was 36. So that time I subtracted by mistake, but we will add. Now, what I was thinking that always don't have to copy. Actually, there is also in the book it is given like that. I do only this one. Let us see whether I never tried like that. Now you cut it here. 2 into 4 is 8. D is my 13. 24 is 8. 8 comes here. 65. 465. 4 is there. Don't have to repeat all these numbers all the time. When you are working out on a piece of paper, you can do that like that. Like your division, conventional division, you keep on bringing out the digit one by one. That way, bringing out the digit one by one. Then again I cut, and this 5 into 4 is 20. I never tried earlier actually. 20 becomes 66. And becomes actually 666. So now 666, 66 and 6. It becomes 96 and 30. 6 into, sorry, 24. Actually. 6 into 4. 24. 90. So 0 I can cut directly. 9. 9 is not divisible by 13. So this 9, 66, 465. I mean, not 465. So all these 6 for this, all these 6 for these things. Finally, this is not divisible by 13. It looks complicated. Mean to say always don't have to copy. What is the rest of that? One by one, you can take the digit also. But actually, it is like this that I have shown there. This way. Right, everything right, even right. Even you are subtracting, and then. Any question? Anything needs clarification?
Sir, not understood division by 13, no, that method. Not able to understand.
Oh.
What actually you are doing, it is not quite audible also, so I could not follow up actually.
Oh.
No, audible, it is audible. I mean, the audio
audible
is okay.
But
then you could not understand. That's the
I could
point.
not understand
Yeah.
in a proper way. So just like a dumb man, I am listening. That's all. But nothing
So
is.
any number, other numbers you do actually it's a already divisible by 13. I'll take a number.
You please take a 4-digit or 5-digit. Let the digits be 5. You take any method, and what actually you are doing, how you are doing is just explain.
You suggest one number better. You suggest a number. I will divide by.
No, sir, you please take no problem for me. Only I have to understand the principle. The way you are doing, and that's what I want to understand. You take any number.
Let us take a number. Hmm. 18369. Okay.
Oh, okay.
Now, in case of 13, the oscillator M is equal to 4. Okay.
Okay, sir.
Okay. Now, here this part I am cutting first of all.
Okay, sir.
9 into 4 is my 36.
Okay.
I will add this 36 here.
Okay.
Now again I cut it.
Okay.
This is, I mean, cutting it and doing it, multiplying with the oscillator, this 8.
Okay, sir. Okay. 2 into 8. Okay.
Now this I already cut. I do not add with that. 195.
195 and 5 cut. 5 into 4, 20.
Then again 5 cut.
And 20, we have to add to 19.
It will, when you practice it, it will flow actually line by line. You don't have to do anything. 39.
39
39 is divisible by 13. So this 39, 195, 1872, 18369, everything, all these things are divisible by 30.
183.6, 187, 19, and 39. Am I correct?
Step by step,
Okay.
all these things are.
All the 4s are cut by. Now I understood, sir. Thank you very much.
So this is the matter of practice only. So please do your homework. Test whether these are numbers. It is your choice. You positive, negative, what minimum oscillator you use. Something is by 19, something by 31. Divisible by 31 is so easy. It's just the oscillator is -3. You simply do.
No, this oscillator is a guesswork.
No. So guess what? Start with
here,
the guesswork, of course.
In the example you have solved just now, the divisor is 13, whereas you gave m is equal to 4, right?
For 13.
Yeah.
And
for
m is equal to
13.
-4 was for 41.
Sir, instead of being a guesswork, I think we can do it as if we take the multiples of 13 that has a last digit 9. So from that we can take the oscillator, I think. Like
Yes. Yes, that is good. So multiply that a number in case of ending in 1 and
1 and 9.
In case of ending in 3 and 9. So in something ending in 9, you don't have to do anything.
Yeah.
This is 19. We know that for 19 the oscillator is 2 because 19 itself is 20 minus 1. So oscillator is 2. Okay.
No, which one, madam? You are telling?
No.
The last
Sir,
one?
for example, if we take the number 13. Yeah. No, go ahead, sir. Yeah.
Yeah. That's what I'm telling. Something ending in 9. Something ending in 9. 9, 19,
Okay.
29, 39, etc. Say 49, 59.
Sir, I have a doubt.
Please.
Oscillator, it is 10 minus 1. So oscillator is 1 plus 1. It is 20 minus 1, so oscillator is 2. For 29, it is 30 minus 1, so it is oscillator is 3. This is 4.
Okay. Okay.
This is
Okay.
5. This is 6. Instead of something ending in 3, 13, 23, 33,
Okay, sir.
I multiply by 3. So 3 into 3 is 9. So oscillator is 10 minus 1. 1. Did I miss one? 13 or 13, I multiply by 3, which is 39. And 39 is 40 minus 1, so oscillator is 4. 23 I multiply by 3, 69. 69, this is 69 is 70 minus 1, oscillator is 7. 147. For 33, it is 147 again. 33 is 99, 10, oscillator is 10. 43. It is 129. 129. To multiply this thing, 129. So it becomes 130 minus 20,
13.
13. So see, the difference is 3 up there. 1, 4, 7, 10. Because you are multiplying with 3. Here there is no difference. Difference is 1. 1 difference. Here difference by 3. And again I do or something ending 7. Say 7, 17, 27, 37. This also I multiply by 3. So multiply by 20, it is ending 21. So this is 51. This is 81. Multiply by 3. And so on. Now, oscillator will be how much? Minus 5. Minus 8. Minus 11. Or something ending in 1.
Yeah, Murthy garu, are you able to follow?
Yes, sir.
Right, good.
Now again, 1 is also very required. They also multiply by 3. Don't have to multiply by 7. Then it will be higher. It will be positive oscillator. You have negative oscillator. Always multiply either multiply by 3 or don't multiply by anything. So 1, 11 don't multiply it. Or what is my cursor? Or 1, 11, 1, 11, 21, 31, 41. My oscillator are no, not 1. 1 is of course not falls under that. 11, 21, 31, 41. 11 minus 1. For 21 is minus 2. For 31 is minus 3. 41 it is minus 4. For 51 it is minus 5. For 61 minus 6 and so on. Good enough? And therefore any factor, this is the total table. I did positive and negative, but actually is Madam you pointed out very nicely. Thank you very much. You did it very nicely. Either you keep it as it is or multiply by 3, and that is the way to find out the oscillator. Please, thank you.
Sir, I have a question.
Yeah.
Sir, I have a basic question. D is equal to 13 and M is equal to 4.
Yeah.
Now, what is the basic method to find out 4?
Oh, that's what I'm going.
No. Just I will tell you what I have understood. 10 minus 1 mod D is equal to 0.
Yes.
So 13 is a divisor. Now select 13, 39. So
Exactly.
then I get to M is equal to 4.
Exactly. That is the way.
Okay. Now, instead of 39, I select 26. 26 is also divisible by 13. And then for 26, I am not getting this one 10 minus 1. 10
26,
minus
26, why are you doing it? The oscillator method is applicable for digits ending in 1, 3, 7, and 9. Suppose 26 means is actually 13 into 2. So
1379.
1379.
For this one only I got that out, sir. Okay, you give after.
Initially I told, no, initially I told. For composite numbers, for composite numbers,
Where it is written? Oh, yeah, 1379.
divisibility by
Okay, sir.
composite numbers, divisibility by its factors. 42 is divisible. So 26, something will be divisible by 26 when it is, it should be even number, so divisible by 2, and it should be divisible by 13, so that it will be divisible by 26. And here the proof was there that this algebra somebody can go through. I will not go through this. Okay, there is an algebra by which it is being proved that if we find the oscillator, this is the proof, and this somewhere this 10n minus 1 is coming. If the 10n minus 1 is d is 0, then this thing is 0. That means
from this one only I am finding out.
From these two equations, my task is only to find and aim so that this is 0. My part is over. Now I follow the procedure. Then I only keep on testing divisibility with a smaller number. Then automatically my bigger number will be divisible by this formula. This algebra is there for this.
Okay, sir. Okay, thank you.
Now I come to another concept. Suppose you are asked to test divisibility of something by 9 you have done, but suppose 99, somebody gives you for 999 or 4 numbers of 9, whether some number is divisible by 999, all these things, what do you do? Do we do all these procedure one by one, or some factor of 999? There is a procedure called multiplex oscillator. Multiplex oscillation, which is again the same algebra is there. I have worked out the algebra. I found that there is also 10m 10 to the power n m minus 1 is divisible by not divisible by d, and that will ensure the divisibility. Yeah, this is the ensure divisibility, and finding the procedural modulus the oscillator e 10 to the power something else. When it is earlier it was 10m minus 1. Now it is 100 minus 1, 200 minus 1, or 200 plus 1, positive and negative, 300 minus 1, 300 plus 1, like this. So, the procedurality. For divisors of the form 199, 299, 399, we could take accelerator as 20, 30, 40, etc. instead of etc. In our, so far we have learned, it should be very large, like 20, 30, 40, etc. Instead of this simple oscillator, in these cases, we may take as well 2, 3, 4, 5 as multiplex oscillator and take 2 digits at a time. Let us check whether 2196155 is divisible by 299. It is second order oscillator of 299 is 3 because 300, 3 into 100 minus 1 itself is 299 or divisible by 200. First we write dividend in the group of 2 from right, mind it. 55, so this given number is this one. I write it 55, 61 and so on this separately. And then I do 55 into 3 directly. Don't do 5 and 5 one by one. 5 into 30 and 5 into 30. No. My oscillator is 3. Multiple oscillator, second order. So 2, it becomes 221. It is a large number. So again 2 to this will go. Again I separate into this one, and it becomes 229. That's divisible. This large number is divisible by this large number is divisible by 499 or not. So I this group into two places, and then last one 69. See, I've cut it 69 here. The 69 for 499, my oscillator was 5 plus 5. multiplex oscillator, second order. So 2 at a time. So this is plus this one, this again this number I get it, cut it like this. Here he cut 87 into 5 we do, and this thing. And again I do this 25 I cut here, and 25 into 5 this thing. And again I do cut 86. So 86 into 5, so 14, but 97 is cut. So 14 plus 97 into 5 is 499. Thus it is this all these numbers are divisible by 499. So if this is divisible by 4, again this multiple oscillator opposite side, negative of that. So this number is cut. This thing is subtracted with this is the 401, which oscillator is -4. Second order oscillator. So 2 at a time. This goes. Again I cut it here. 1 into 4. Again I cut it here. This is this by mine into 4. Cut it here. You just keep on looking, and you just you see the example later and you practice yourself. And is not divisible. So this way it divisible by 5,999. This is the third order oscillator. So this is, you have to group in 3. Okay, there are 3 numbers of 9. So this I cut. This number plus 569 into 6. This is this one. And again I cut here. Again I cut this into, and so on. Oh no, not here. I cut here. No, this is not. We already in the process of calculation now. This one inside plus 617 into 6. That's divisible. So this one also, this is third order oscillator is -7. So you are -7, you're doing 3 at a time and -7. So just this is for general calculation that divisibility, I repeat 9 numbers. This number is 90, divisible by 99, divisible by 99, 99 or 4 numbers of 9. In case of 9, we kept on adding all the numbers. So grouping was one group. Here for 99, it will be grouped into 2. So that way you see the oscillator is +1. Oscillator is +1, but second order oscillator. So keep on adding all these 2 group of 2. So it is divisible by. Here you group into 3, and so that it becomes either it will be 99, 99 all could have been done with multiple of 999. This whole big number is divisible by 9999. So we take groups of 4. Groups of 4 we take. So this thing are divisible. So this is 999. So divisible by 9. Earlier we did for 9. Don't have to do so much of thing because the oscillator is +1. Similarly, for hollow numbers, hollow number is 10 to the power n +1 numbers. This thing divisible by 1001. So it is actually for 11 it was oscillator was -1. For 101 also it is second order oscillator is -1. All are -1, but second order is. This order is 3. And how many grouping will be done? This is 1011, 1001, divisible by 1001. So it is alternate. In case of 11, we did alternate. Here also we are doing alternate. But with group of 3. See? In the group of 3 you are doing. From right. So this is not divisible. This is also due, all these things positive. This is 0, so this is due. Hollow numbers are special cases where nth order multiplex oscillator is -1. Then the process leads to alternate sign additions. This is grouped by n. Now, what will be about the divisibility of 421? Here also, we have to find whether this 421 is anything close to, this is also a guess. This is also even difficult guess. So 421 is equal to 421 into 19 is 7,999. So third order oscillator is 8. 7 plus 1, 8. So it is 8,000 minus 1. oscillator. So we have to play with group in 3 and use the oscillator 8. In this 440, suppose divisibility about 409 and 489. So this multiplication of these two, both of them can be used as this 2 lakhs 1. So fifth order negative oscillator is -2. So this way we can do very quickly. They will march very quickly actually. Okay.
Yeah, Gautamji, it's 8 o'clock.
Now what I told you in the last, is it was it?
Yeah, students should answer whether it is clear in the last
This is
part.
just a concept I did. The practice actually is it will be very big actually. Not big. It's matter of practice actually.
Sir, we need to practice, sir. That is the problem.
Huh?
We need to practice more.
Yeah,
Then
yeah.
only it will be clear.
Don't worry, you understand the basics what has been taught, and then maybe
Yeah.
in the second level, we again will touch upon
Second
these
level, we
things.
charge these multiplex oscillators. Actually,
Right.
Okay.
now application of this is just for academic interest, and those of you who are in computer and so on. Applicability of Vedic mathematics is for hex numbers. So the Vedic mathematics has been designed. Is it for only for applicable for decimal numbers? No, hexadecimal numbers with base 16. So they are digits are from 0 to 9, 0, 1, 2, 3, 4, 5, 9, and A, B, C, D, E, and F. Place values from right are unit, then 16 to 156 and so on. Thus the hexadecimal number 9CE will have the decimal value 9 into 256 plus C means 12, 12 into 16 plus 14 is 2510. This is 2510 decimal, our number, our known decimal number. This can be expressed as 9CE in case of hexadecimal number. All the Vedic mathematics principles used in case of decimal numbers are equally applicable in case of hexadecimal numbers. Computers and mobile devices can be more power efficient if their architecture, whole circuit architecture is designed on the basis of Vedic mathematics, especially the Urdhva Tirjagabham multiplication method instead of the conventional multiplication method. So consider adding using vinculum in case of hexadecimal. So I myself tried a few days ago and I got interested, so I thought I'll share with you. Consider these two numbers. See here again, in case of our vinculum, what did I do? Something is more than 5, we more than or equal to 5. For 5 we can decide, but for more than 5 it is we have to decide by that we have to convert into vinculum. Similarly, here it is more than 9, we convert into vinculum. So we are given the number, these two numbers are given to me. 46 EC475 and 4E85. These are big numbers, more than 9. So these are difficult to, we convert it into vinculum. 4, 7, -1, -4, but these things become, this became like this in different 16 places, like ekak dashak shatak, ekai dahai satkara hajar, or one unit 100, it is powers of 16. So this, when I add them, the adding very easy actually. So 3 - 1, you can see very easily how it is adding. Adding is very clear. Earlier, suppose you had to add C with F, it would have been very difficult. Now it is adding is very clear here. You can see by, like, as if it is we are adding decimals. It is similar to adding in decimals. After this when get cleared, again I do clear the vinculum. 8 and -4 becomes this 7C. See, 8 - 4 becomes 7C, and then this, after clearing the result, becomes this. So even vinculum method can be done in using hexadecimal. This is the multiplication method. Multiplication near a hexadecimal base. 16 to the power something. Base is here. Base was the 16 to the power 6, which is actually 16 to the 6. You can calculate in this one. So it is again this minus this cross subtraction, and then multiplication of these two. This becomes this minus this first part is this minus 13, or this minus 20, and this multiplication of these two. So this actually finally become this one. This is the multiplication of 30 into 24. Means not 13 into 24. This 1, 3, and 2, 4 in hexadecimal, and these are this minus this. The same kind of thing applies actually. Same kind of formula applies. Urdhva method also using this 3 into 3 plus 4 into 4, whatever it is. So this is C comes here, and then all these. Sorry, 4 into 3 is 3 into 4 is C. When 12, so it is C comes here. 4 into 4 plus 3 into 3, and this 19. 19 is actually this 19. 19 is 1 9. This way it comes actually, and works same as a decimal.
I think we can have this
Then
in the
also
second level. Yeah.
Using Excel also, I found it out. 1 by 2f is this much. Those of our interest in Excel, it comes initially from this thing, and then we do hex to deck. The function called hex to deck. Deck to hex. This deck, this decimal number gets converted into hex number. Dex to hex. Deck to hex. A function. Those of our interested in Excel, this is same as decimal. So my thing is that I wanted to tell you that these are similarly applicable in case of hexadecimal. So these are not limited things. It can be even in today's computer world. Basic mathematics is equally applicable. That was my final conclusion is this. Okay, thank you.
Yeah.
Okay. Thank you, Goutham ji. Thank you so much. Really, you got us know about Vedic mathematics. We know only mathematics so far. Now, what is Vedic mathematics is not known, is a mystery. So I'll request all participants to thank Goutham Mukherjee for taking the classes and going through. And you see, he's got so much now left to teach that will be covered in level 2, advanced level course. Those people who get qualified in this will be given admission in next level course, which is going to start in July. So now you get the taste of what is going to come in higher level. So request all of you to thank Goutham ji for taking this lecture series. Starting from CC Babu Garu.
Yeah. I mean, it is a fantastic class on Vedic mathematics. This is the third time I'm listening to him, and every time I improve myself also. It is very amazing to know about Vedic mathematics. The real part of Vedic mathematics will come in the next, hopefully, in next levels, as we know more from Dr. Mukherjee.
Okay. Ramani.
Babu Garu, can we do the pradhana and then have an open session?
No,
people want to
open
leave.
session, just wanted to thank him. Okay.
Right.
So let us now, okay, Shastri Garu.
Thank you, Goutham ji. You have done, you have educated us. I could understand very well. And it has created interest also to learn more thing from you. So sincerely, I thank you very much. Namaste.
Welcome.
Okay, now we will go for Prarthana. Dr. Sharda, please chant Prarthana, please.
बहवः धन्यवादाः गौतम महोदय। स्वस्ति प्रजाभ्यः परिपालयन्तां न्यायेन मार्गेण महीं महिषाः गोब्राह्मणेभ्यः शुभमस्तु नित्यं लोकाः समस्ताः सुखिनो भवन्तु। काले वर्षतु पर्जन्यः पृथिवी सस्यशालिनी देशोऽयं क्षोभरहितः ब्राह्मणाः सन्तु निर्भयाः अपुत्राः पुत्रिणः सन्तु पुत्रिणः सन्तु पौत्रिणः अधनाः सधनाः सन्तु जीवन्तु शरदां शतम्। सत्यं वद धर्मं चर स्वाध्यायान्मा प्रमदः सर्वे भवन्तु सुखिनः सर्वे सन्तु निरामयाः सर्वे भद्राणि पश्यन्तु मा कश्चित् दुःखभाग् भवेत्। ॐ शान्ति शान्ति शान्तिः। ॐ पूर्णमदः पूर्णमिदं पूर्णात् पूर्णमुदच्यते पूर्णस्य पूर्णमादाय पूर्णमेवावशिष्यते। ॐ शान्ति शान्ति शान्तिः। सर्वे जनाः सुखिनो भवन्तु। स्वस्ति। धन्यवादः महोदय।
ధన్యవాదములండి శారద గారు. Now let us recite national anthem.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंधु गुजरात मराठा द्राविड़ उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्छल जलधि तरंगा तव शुभ नामे जागे तब शुभ आशीष मांगे गाहे तब जय गाथा जनगण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे। जय हिंद।
జై హింద్.
जय हिंद।
ధన్యవాదములండి చల్లా
ధన్యవాదాలు
చిత్తూరు గారు.
Thank you very much.